right, so the slope is, derivative is the same thing as the slope of the tangent line. So it's not the same thing as the slope. I know we sometimes shortcut what we say, but it's the same as the slope of a tangent line. So given any kind of function I decide to make, if I pick a point and I want to find f prime of a, then I pick a point, I call that point x equal to a. The answer to the derivative will be the slope of the line that's tangent. So this line, if I was to find the slope of it, that would be the derivative at x equal to a. So that's the most basic thing that we learned. We learned way back when what the derivative was in terms of graphical. And then the other name for it, instantaneous rate of change. I have seen AP problems where they ask you for the instantaneous rate of change at x equal to 2. So you have to know that that means find the derivative at 2. Okay? Then, just a reminder that the actual word slope, meaning the formula y2 minus y1 over x2 minus x1, the other way you'll see that formula, f of b, second point, minus f of a, first point, all over b minus a, that is the same thing as average rate of change. And then you heard me say instantaneous is the slope at 1 point, average is the slope at 2 points, between 2 points. Okay, so that's just vocab. You have to know your vocab in case they ask it that way. They may ask you for the average rate of change. They may ask you for the instantaneous rate of change. Travis, pay attention. Make sure you know which one is which. All right, now that we have that, we can go through all of our rules. So product rule, I'm going to give it to you in notation to start. So f of x is equal to g of x times h of x. So that would be the function. Product rule says that if I want to take its derivative, take the first function, multiply by the derivative of the second, plus second function, multiply by the derivative of the first function. Doesn't matter the order. You can switch the two products around, or within a product, you can switch that order. Therefore, in your packet, number 25, you can try that one. So your AP test likes using e to the x a lot, e to the u, because if you do a product with e to the u, or you do a quotient with e to the u, it becomes a factor. That's why they like using that function. Other reasons why they like using the function, sign charts, become pretty easy to do with e to the x, because e to the x always has the same sign. What sign? Positive. So those are the reasons why they like using e to the x. So starting off, common factors. E to the x, I guess I should put the x in front in terms of notation. So x e to the x is my GCF. First way that you want to think about factoring. And then I have left, I think, an x and a plus 2. Right? Letter C. We good? All right. Let's look at quotient rule. So quotient rule. And these are all rules, yes, you already know. You should remember how to do them, but if you want to have your summaries, you can do those. All right, so let's call f of x g of x over h of x. Therefore, the quotient rule says low d of high minus high d of low all over low, whole thing, squared. And I'm completely fine with you remembering it as low d of high minus high d of low all over low squared. That way you remember the order. Order does matter because there's a minus. So you have to start with this guy. Does matter. You can either start with g prime or you can start with h of x, but you cannot start with the second term g of x, h prime of x. The minus sign means that you have to do this term first. It has to be the positive term. All right, the one I would like for you to try is this guy, 22. You try 22. All right, looks like most of you guys are getting down to your answer. So remember, first thing you want to do, take the derivative first and then substitute in the value. That order does matter. So the low, d of high, minus high, d of low, all over low squared. And then I want to find this at pi over 4. So tangent of pi over 4 is how much? 1 times 1 minus pi over 4 times the secant of pi over 4 squared. So that would be the same thing as taking the reciprocal of cosine of pi over 4, which happens to be root 2 over 2. So take its reciprocal, 2 over root 2, and square that guy. And then all over tangent of x, which is 1 squared. So you want to make sure you know your cosine, sine, tangent values really well so that you can do the reciprocal values. And then you end up with 1 minus, that's 4 over 2, so 2 pi over 4 times 2, which equals 1 minus pi over 2, I believe. So, quotient rule. Then you have chain rule. Okay, so I'm going to give you your chain rule two different ways. I'm going to start out with the definition that you should know, that I'm a little more familiar with, g of h of x. So chain rule is anytime there's a function inside of another function. That's your chain rule. Okay. So f prime of x is equal to g prime, derivative of their outside. I'm going to leave the inside of the function exactly the same as it was, and then I'm going to multiply by the derivative of that inside function. Okay? That's the way that I did the notation before. I'm going to also show you another notation, and then I'll also write the word notation. So can you guys write, actually let's have you do that. That's notation. Write it in words. What are you familiar with in terms of in words? How do you know your chain rule? Huh? No, write it. In words. I write it on the board every time we do chain rule. And I say it every time, and I just said it a second ago when I did it. Alright, so, and I will give you a third way, so I'll put this one here. So the chain rule is derivative of your outside. I just said it a second ago. Leave your inside, multiply by the derivative of the inside. I am going to show you one other way. So those are two different ways. There is a third method that you'll see. You won't use it, but you may see it, and then kind of the mathematical notation lends itself to understand that you can do stuff with differentials. What I mean by that is if I give you a function that's actually another function y in terms of u, then the derivative, actually wrong notation, the derivative of f with respect to x would be the derivative of y with respect to u times the derivative of u with respect to x. I want you to see that because you can multiply differentials. You can actually divide differentials. What happens when you multiply those differentials? You get dy dx. That's why it works. Okay? So that notation is not as familiar to you because I don't use it as often, because most of the times we don't write what our two functions are, the y function and the u function. We tend not to write that, so I don't use that one as much. Alright, so given that, I would like you to try number 4 to start. Matthew, go ahead and put it in my desk, please. So differential notation? Differential notation says that if I want to find the derivative of y, it's respect to what? There's no u. So if I want to find the derivative of y, sorry, that's where I am, up there. The differential for the derivative would be with respect to x. And the derivative of this with respect to x is? So this one, if I ask you to find the derivative of u, it is with respect to x. There are multiple ways you can do it. I want to find dy du. How can I make dy du happen? Based off of this differential and this differential. Ooh. Yes. You could. I'm not going to do that to start. But I will end up writing that in as one of my methods. Matthew? The reciprocal? What do you mean? Of? So this would be the same as dy dx, and then reciprocal this guy. Why would that work? Method 1. Method 2 is pretty much the same way. There's another way, just by looking at them, that you can make that happen. Yes? Not going to take that one just yet, which is actually similar to what Ty said. I'm going to use that as my third method, but thank you. And that is correct. Nice to know you guys don't know how to divide. Which is the same thing. Dividing by a fraction means multiplying by the reciprocal, so they're the same method, just looking at them two different ways. And then the third one that I'm hearing from you both, so you said take this guy and do what? Okay, so then this one, I'll squeeze it in blue. dy becomes 2x dx. du becomes 2 dx. And they're asking for this. So what do? Divide them. Takes some thinking. What you guys tried to do is take the problem, and I had chain rule written, so you wanted to make it a chain rule problem, and I said, no, don't do that. I said, it's the concept of differentials that I wanted you to take from that, the notation. How you can mess around with that notation and do arithmetic properties to the notation, which is why I gave you this problem next. Because every single one, the answer is what? The answer is definitely not it. Oh yeah, it is. Definitely is x. And all three of them are equal. What do you mean you don't see why that's the same? Oh, what you were saying. Solve for x and substitute that. What would you do with the x? Oh. To where? There's no x over here. It may work out. No, it wouldn't be my inclination to do it. But it may work out. Okay? I'm going to actually pause that. I was going to say something else. I think they just came back with a snow contingency plan, which actually means that I'll be able to take a day out of spring break. So I'm not going to give you guys these until tomorrow, because I'm going to go check the snow contingency plan and see what days you guys still have to be in school. I think they took away your Monday. If they took away that Monday, I'll probably move one of the days to that day. It actually helps us out a little bit. So I'm going to redo these before giving them out. Homework is the multiples of 3s. There's one free response question. Yes, I would like you to do the one free response in the back. If you have any questions, today would not be the best day for me. Tomorrow will be, because I am going to start the review for the test at 11:40. All right? So if you need to be here for the test review, please be here for the test review. You already asked me that. Yes. Yes, I can. 31, right? Yeah, robbed you of your last page, I think. I feel like that's not the first time I've done that, too. Yeah. I'd like to say that I am secretly trying to make you fail, but it's actually not me adding it, so someone else is secretly trying to make you fail. Yeah, they probably just missed the last page, but yes, I will give that back to you. Alrighties. Let me take these guys from you guys. Alright. Your graded test, yes. What did I, oh, sorry, hon. What did I do with your graded test? Check in there to see if it's not in there. It might be in there. If it's not in there, it's probably in my office. I have to run and grab it. Yes, hon. Huh? Oh, the phone that I'm not supposed to see. All of a sudden I see it. End of the day. Yeah. Come and find me at the end of the day in the math office. Okay? No, I saw that a long time ago. I was being nice because I thought you'd be smart and put it away. Yeah. Yeah, but he figures about 10 minutes later that I really didn't see it. It's not in there? No, because I don't know where it is. It didn't come from a desk.